I request our FDP coordinator to present a bouquet to our esteemed guest. Now I feel honored to introduce you all to our resource person, Dr. Pal. Dr. Pal received his BTech and MTech degrees from the Institute of Radio Physics Electronics, University of Calcutta in 1992 and 1994 respectively. In 2001, he was awarded the Commonwealth Scholarship and pursued his PhD at City University, London, in the field of fiber Bragg gratings-based optical fiber sensing and instrumentation. Mr. Pal returned to CSIR Siri Pilani in 2004 after completing his PhD. Presently, he is leading the Optoelectronics and Micro-Opto Electromechanical System Group. In addition to the area of FBGs, his present research lies in the area of integrated optics involving the design and technology development of various passive photonic components, waveguide gratings, and GAN material based on LED devices. He has authored and co-authored over 100 scientific and technical papers in various reputed national and international journals and conferences. He served as a reviewer of various national and international journals like IEEE Photonics, Technology Letters, Review of Scientific Instruments, Sensors and Actuators, a Physical, Optical Express, Optical Engineering, and so on. Now I take the opportunity to request Dr. Pal to address the gathering with his words of wisdom.
This is better. This is the pointer. Forward, backward, huh?
Next. Pointer.
Very good morning to all of you. So I understand all of you are coming from all over India, various places, isn't it? So from northern of India, how many of you?
Maximum north.
Maximum northern. From eastern, western, or south? South. Okay. East, Jamshedpur. Okay. So all of you are faculty in colleges? Students doing. Okay. Students. Student means doing your PhD there. Huh?
UG, PG.
UG, PG also. Okay. Fine. Very nice. So this faculty development program, this program in fact IoT enabled PLCs. This is very much important and very much relevant in today's context. But my lecture topic would be slightly different in the context that, am I audible? Yeah. Context that IoT is network of networks, okay? But how to connect? Network means connection is there. Then what to connect is there. My talk will be for that. So connection with various sensors, various devices are there. And so my talk will be semiconductor devices for IoT, can be used for IoT, and some related activities what we are doing at our institute, that is CSIR planning. This is the neighboring institute, and I understand that as a part of your program, there will be a visit to CSIR for all the candidates. So when you visit the institute, you will get much more flavor that what types of works are going on, what projects are going on, and what are the industries, what technologies are being developed, and to whom we are transferred, and what aspect they are carrying forward further, kind of thing. So, laptop? नहीं, इसमें भी हो जाएगा, no problem. And for CSIR CD, just before the start of my talk, I should say that one, that CSIR CD is Central Electronics Engineering Research Institute. It is one of the laboratories, one of the 37 laboratories of CSIR, that is Council of Scientific and Industrial Research. And CSIR is having 37 laboratories, what I mentioned. They are working in various areas, starting from biology, chemical, physical, then metallurgical, glass and ceramics, botany, various things in 37 laboratories are there. And CD is working on electronics. So being a national laboratory of CSIR, our part will be to work and carry forward the work in the area of electronics. And as a part of our responsibility, we have to carry forward our work for the society, for strategic organizations, that means for DRDO or ISRO or Atomic Energy, because as a mission project of their projects, so some of the activities they can also offer to us, what we do for them. So those responsibilities are there. So, oh, it's not going. Yeah. So briefly, I start that the institute was established in 1953, and Pandit Jawaharlal Nehru founded the stone, laid the foundation stone, and after that, from 57 onwards, established in 53, and after the development of building infrastructure, the actual R&D started from 57 onwards. So if I categorized in three different eras, then first era I consider up to 75, then 75 to 2000, then 2000 onwards of what we are doing. So during that time also, so it is, in fact, CSIR was established before independence in 42, and CD was established in 53 after independence. And at that time, our main emphasis was there that we need to develop, or we need to establish various organizations who can support the Indian industries for self-reliant. It is again coming back nowadays. So during that time, CSIR CD in that era up to 75 generated 47 technical know-how and transferred 70 industries for commercialization. And some of the major thing, what we'll be proud to mention, that earlier the black and white television was the very first developed by CSIR CD. So those television receiver, diesel electric locomotive drives, so up to very recently, those drives were also being used by Indian Railways, and various other instruments and devices like magnetron and a scanning electron microscope to view very small things, micro level things. All those things were developed during that time. Technologies were developed and technologies were transferred to various industries for further development. In the era of 75 to 2000, in that time, with the help of UNDP, United Nations Development Program, and UNESCO, the Advanced Center for Advanced Technology for Semiconductor Devices, that has been established in our organization. And from that time itself, the semiconductor activities started in our organization. Now you are seeing various solar PVs, silicon solar cell, starting from other silicon to other solar cells as well, made of gallium arsenide. Different combination of materials are also, people are working nowadays. Organic solar cell are also working. So during that time, Siri worked on this solar PV, and tracking system for the optimization of the solar panel, that is still available in the rooftop of the Siri. Till now, you can see that one. Hybrid microcircuit for SROS and INSAT series satellites. Those circuits were developed during that time. ASIC chip, application-specific integrated circuit. During that time, we have developed for CDOT. You have all know about CDOT, Center for Development Telematics. Motorola MC68010 equivalent microprocessor was developed, and many more. And in the present scenario, if I see that Siri is working in 3 areas. One is semiconductor device, what I mentioned. Another is vacuum electron, which is related to high power microwave devices. Earlier, only microwave devices, high power, we were working, just like klystron, magnetron, gyrotron for power generations and power supply energy. Now, along with that, we are going for the system development with the devices as well. So high power microwave devices and systems. And another area, sub area in that area is terahertz and plasma devices. So now terahertz is one of the niche areas where researchers are working worldwide. Various devices, systems for imaging, for scanning, without any health hazard. So all those applications are there. And for plasma devices as well. For one example of plasma devices for switch application, for high power devices application in microwave range, as well as for the devices just like UV light, UV source creation. At present, in fact, what are the UV sources are available in the market? All those are mercury based, because mercury is emitting the wavelength in the range of 254 nanometer. But the main disadvantage is that mercury is very much toxic, and which is environment hazardous. So very small amount of mercury can contaminate the environment, can contaminate the water forever. So that much contamination is there. So worldwide they have started that to omit or to avoid the mercury use, and that's why what you are seeing nowadays, all those are, I'm not sure, probably those are made by LED, if it is not too old. Earlier halogen bulbs were there, but those were very much energy inefficient, and then started fluorescent bulb kind of thing, tube light and CFL. compact fluorescent bulb, but all are made of mercury. So that's why you cannot see any CFL nowadays, and tube lights also, because of this thing. And what we are, or all are working on the area of LEDs. They are using that one. So Siri is also working on that. I am having few slides on that also. So that can be used for indoor lighting, outdoor lighting, for systems development as a source kind of thing. So all those things can be done. Similar can be done using plasma as well. For electronic systems, what we are developing, the devices in the area of semiconductor or in microwaves, we can connect all those things to make a system to give the end-to-end solution for that one. And not only that, what the devices we are fabricating in our lab, what the devices or discrete sensors are available in the market, we can use also those things to make a system that which is having the demand for the industries or for the societal application. So those kind of thing we are doing. We have high performance computing facility, DGX, which is capacity of 5 petaflop and 100 terabyte. And what I mentioned, that systems design and development along with all the devices. For the semiconductor devices from which I belong, so those we are working in the area of silicon-based devices, design and fabrication. Gallium nitride is another potential material what we are working. MEMS, you have heard, I think, that is micro electromechanical system, very miniaturized devices and microsystems. Those are also we are working on that. Another is LTCC, that is low temperature co-fire ceramic. That is one kind of material can be used to package the devices, and not only that, those materials can be used for making various micro devices as well. Particularly for micro heater fabrication, LTCC material is very good. We have 2 extension center. One is in Jaipur, one is in Chennai. They are also working on electronic systems. That means what are the devices interconnecting all those to make end-to-end solution to make the system. Using softwares, AI, ML, everything are there. IOT-based systems, they are also working. In addition, in Jaipur Center, we are having testing and calibration center, because what the devices or systems we are making or what people are using, whether what they are measuring, whether that is accurate or not, whether that is correct or not. If it is correct, that is fine. But when we are saying if it is correct, on what respect, with reference to what? So that standard and to calibrate those systems time to time is very much important. Otherwise, those are electronic systems. If you switch on, that gives some values, but whether those values are right or wrong, you have to check those things. So you have to calibrate across the standard systems time to time. So that is also very much important. Those we are creating some facilities for solar grid, grid-tied inverter facility, and similar to other things. And one good thing is the pilot production facilities. So pick-up place facility for making the cards, the various cards. So you can we can fabricate that one using different chips, and those capabilities 27,000 chips per hour kind of capacity is there. So that is in full swing. So various industries are working on those on service basis. So we are planning to enhance those capacities with that one also. So now what I am mentioning. So in your context, what is the definition of IoT? What I just mentioned, that it is the network of physical objects or things, and those are embedded with electronics, sensors, softwares, and network connectivity. And that enables those things or objects to exchange the data, and that exchange data means transmitting the data or receiving the data kind of thing. So both can be there. Both, in fact, both should be there. The other points are there. Remote access, obviously, that is very much important. So that allows object to sense and to be controlled remotely with the existing network or infrastructure. So for that, existing network may happen, or if we need to upgrade those network, that also we need to do. Connectivity, because it creates the opportunity for integration between physical and computer-based systems, and remotely we can work on that. So there are huge potential and various applications are there. What for? For what? For improving our quality of life. So whatever we are at present, always our main emphasis is that how to improve our quality of life day by day, but with improving accuracy and obviously with economic benefit, obviously. So whatever we need to develop the devices or systems, that should be affordable with affordable prices. That is another important parameter. Go for next. Yeah. So if we check, so those are these, I have taken the figures from net. So if you check the possible applications, so you can think of each and everything can be connected through network. Each and every devices can be connected. So those are every physical devices, and physical devices are being connected through web or cloud, and controlling through software, those things. So go for next. So applications, huge applications in everywhere. So those applications may be in healthcare, medical application, in transportation, obviously is there. E-vehicle, you are now hearing, and automated, autopilot vehicles are now research is going on. Energy management is very much important. I think there is a movement is being taken by Professor Chetan Solanki from IIT Bombay. You may heard about that. That how to minimize the energy wastage kind of thing, because the global warming and everything what we are causing because of all the activities, the average temperature rise is going to irreversible level. So how to reduce that one? Because if we cannot reduce that energy consumption or the footprint of carbon there, so the that temperature rise we cannot come down with that. Now the average temperature, global temperature is I think 13.7 degree centigrade, and as this rate, if the temperature increases, it will be irreversible by the time 2029. So that's why we have to go for that movement of reducing the waste energy, and whatever the energy we are using, minimize that energy. So reduce one thing, reduce whatever we are using. How to reduce those energy is very much important. How to reuse those energy, that is also another thing. Nowadays we can think of every every device's components, it is having lifetime of 2-3 years, maximum 5 years kind of thing. In older generation, they can't think of that. If they purchase one cycle, that is for lifelong. Now it is you purchase one cycle for my son or daughter, maybe 2 years. We use the pen, use and throw. Earlier, we purchase one pen, and that can be used at least for one academic session. That was not ball pen, that is ink pen. Nowadays, nobody uses ink pen. So those kind of things. Think of natural resources, water. How much wasting we are wasting the water, you cannot think of. So at every level, we have to think of how to reduce the water consumption, because the groundwater level or the drinking water level, it is not reusable. So if we are using or if we are wasting, we cannot generate much more. So what I am taking from his words, that whatever we are using, we need to use optimal, and if we try, at least we can reduce to 30% each and everywhere. We can take bath with using enormous water, but how much we are going to waste, you can think of that one. So if it needs 2 buckets of water, we use 4-5 buckets of water for bathing kind of thing. For drinking water as well. Nowadays we are using the RO for drinking water. For what is the wastewater? We should use that water as well. Whatever purpose we can do, and all those things can be utilized through IoT. Very much. Remote control we can do. We can access. We watch television. And whenever there is nobody, we for some work we go somewhere and television is going on. That is on. We switch on the light. We forget to switch off the light. So all those energies, we need to be very much cautious for wasting those energies, because we are thinking of that we are saving our money, but money is not the thing. And we are thinking that we are depositing this money for the next generation. Money will not serve the purpose. If you serve the environment, that will be for the next generation. You are giving something in real to your next generation. That is only the thing. So if you waste everything and if you keep money and to transfer them, that will be not useful to them anyway. And all those things, IoT is very much useful there. The other thing is also there for IoT. The investment is not that much. The software based and whatever the devices are there, you can go for the connectivity, use the open source software, go for the development of those things, get connectivity. The only thing is innovation in your mind, and where the industry demand, and industry demand from here it comes, that where is the requirement for the general public. As a consumer, what my feeling is, so if you think that one, that create the innovation, and that can create the product as a end-to-end solution of that. Industrial management is very much there. Nowadays, so many industries are there. Without, they hardly care about the safety. They hardly care about that waste management, everything, which is very much important for the next generation. Or environment monitoring is another thing. So that's why monitoring of environment is huge. And according to that, we have to act. Not only monitoring, but according to that, we have to implement those things. Media communication, building home automation, those are basically for the improvement for quality of life for all of us. So what is the progress? If we see that those connectivity, it's all about the connectivity. Those connectivity started from machine to machine first, and then with the networking, and now the most revolution came when the smartphone came into account. Now using smartphone, each and everything can happen, and that is the main tool for IoT nowadays you can think of. And along with that, the connectivity of people are also there. So connectivity of people, connectivity of sensors, devices through web. So those are the things now. And what I mentioned, that it is the network of networks, all the networks, and the area we can consider in the area of transport, in the area of energy, and earth environment, for home application, for education. So all those things can be connected. Those points can be connected individually from one area to another area, and that can be connected together as well. But the main criteria is we have to, when we are connecting each and everything, the main criteria will be the safety and security. Security is very much important. Nowadays you can think of that mobile banking is there, but frauds you have to check. So the software should be very much authentic, very much hard level of security, and obviously awareness to the people is also very much important. Speed is also very much important. In earlier days when we joined during 2000 also, we are searching something, we need to go for searching something. We click that one, and then we are waiting for 5 minutes. It is not coming. So by the time it came, we forgot what we were searching for. So nowadays speeds are there, but obviously the demand for speed is also there, because the rate of kilobit per second to megabit per second, now gigabit per second is also the requirement, because the amount of data we need for transferring one thing, I can say thing, from one point to another point. Earlier it was data, voice kind of thing, where the data was bare minimum. Then picture, then now video, all those things we are transmitting. So huge number of data, and data almost on real time we need. So that much speed we need to be the requirement. And in most of the cases, we need to go for that according to the monitor. We need to take the decision, and we need to implement something switch on, switch off, increase, decrease kind of thing should be there. So analytics, those analytics based on the monitoring, we need the data, and based on the data, we have to have some algorithm to take the decision, and those decisions using those analytics, those should be very much correct, and according to that we implement for the controlling. And further, then we go for the management capability for each and everything. So what are the users or in industries, potential use of industries? So this is one example. It was surveyed by GE, General Electrics, that in various industries, in aviation industry, if we consider that 1% of fuel saving, that creates the estimated value over 15 years, $30 billion. So that means if we save the fuel 1%, we can save 30 billion US dollar over 15 years. Similarly for power, 66 US billion dollar, healthcare, 1% reduction of system inefficiency, efficiency, 63 US billion dollar in railway transport. Similarly, oil and gas, so many things. So that's I also mentioned not only those savings, but also you are saving, or you are keeping something for your next generation at least. And also what I was mentioning that for better quality of life, how, for example, we work we are working day by day or everything, but we don't know about ourselves too many things. And to improve the quality of life in that sense also, that where we are going, who you have interacted with. So all those, although those are data based, but based on those data, you can improve your life, or you can further create further improvement. How long you have spoken to your friends. Sometimes it is okay, it is creative discussion kind of thing, but how much creative, or it is just gossiping, we can think of. How long it takes to get the work, the tone of your message, whether your mental mindset, whether it is correct or wrong, whether you are angry or whether you are happy, the amount of text, tweet and update, how much exercise you are getting, so that is your physical well-being to keep you fit, how much you get distracted. And what I have mentioned, that mobile phone is the main use or main utility nowadays, and at the same time it is the main device for distraction. We cannot focus nowadays. In the mindset itself, there is a it is scientifically investigated that focus or concentration you cannot keep for a long time. Maybe you can keep for 3 minutes maximum. Then mind will divert somewhere. The point is how quickly you can take your mind to that, take it back to that same point. So that is the main thing. And you are reading something, or you are going to work something on some subject, keeping your mobile on. If it is on, then some sound will come. Even if it is in silence mode or in vibration mode, some indication is there, and you are getting disturbed. So you have everybody, we have in our mind that some important information is there. We need to check immediately. So we are getting distracted there itself, and our concentration focus goes back. So that is the thing. So that is the main tool for using each and every work, but at the same time, it is the main device for mental distraction as well. So we have to use those devices very carefully. And nowadays, during pandemic, every boys and girls, very young ages, kids are also very much habituated with mobile, without mobile, and that is now addiction. So we need to be very much careful about that also. We have to be master of those devices, not the slaves. Okay. So the thing is that what is the ecosystem? and where are the uses. So what I mentioned that it is using various devices, and devices may be sensors, sensing and actuation is there. It is a combination of various complementary technologies, including sensing actuations. So many sensors and other devices are also there, sensors and actuators. And we need to identify all those using RFID or QR code, barcode, or digital watermarking kind of thing. Then we need to communicate those things from one point to another point, one device to another device. And that is only possible through addressability, and embedded information processing should be there, and user interface. So all those things, and the devices we are using, so those may be sensors, actuators. I am emphasizing on that one itself in my next few slides. And others are according to the network service provider, that may be operator, cloud service provider through data centers, platform providers may be SDKs, and application developers through tools, APIs kind of thing. So I am emphasizing on the now sensors and devices. That's why I told that my talk will be little bit different in that sense, that what are the devices we are going to get connected through IoT, and a bit insight about those devices. Because in CD, we are in 3 areas, we are fabricating the devices as well. We are going to get it connected through IoTs as well. I have a couple of slides for the examples of that one as well. So what are the devices and sensors, actuators we are fabricating that we are using for strategic applications, agricultural applications, healthcare, consumer electronics, industrial applications, so whatever may be. And in all those areas, IoT may be a tool. For devices fabrication, particularly for semiconductors, so silicon is the base and premier material we are thinking. And on that basis, we are on that experience, eventually we are going for the gallium arsenide based materials as well, silicon carbide based devices, even gallium nitride based devices. And initially we were emphasizing on the individual semiconductor devices and technologies to develop those things. And now we are emphasizing on the micro systems as well, systems and microsystems. So we can provide the end-to-end solution for the services. So various technologies and materials we are working for different applications. And gallium nitride is main of those. And based on that, based on the requirement, based on the industry demand and future prospects, we have our facility for the growth of material of gallium nitride based devices as well. So that is very much important. And for applications, power converters, EV chargers, terahertz sensors, detectors, and sources, for 5G applications also we can use those things. LED lighting is, we all are seeing for indoor and outdoor application, automotive, solar, security systems. Silicon MEMS is another thing, going for various sensors, which is micro optomechanical system also. So it may be for spectral sensor, acoustic sensor, vision sensor for various applications, spectral imaging. So if we go for that UV visible spectrometry, NIR spectrometry, or MIR spectrometry, we can cover the whole range of spectrometry, and those can have various applications in industries. LTCC that can be used for electrodes, individual devices, that can be used for packaging as well, those devices. Vacuum electronic devices, particularly for microwave devices, for RF sources and amplifiers, mainly we are using for strategic applications for ISRO, DRDO, atomic energy kind of thing. amplifiers like TWT, traveling wave tube for amplifying very high power kind of thing. So those things are also there. We are working on that. When you visit, you can visit all the labs there. Plasma devices, what I mentioned. So various applications we are working on: water, food and agriculture, and high power terahertz sources. We are developing sources as well, terahertz sources, as well as systems for application, imaging applications or non-destructive sensing applications to for crack detection for any devices, micro devices kind of thing. Yeah. So those are sensors we are working, and lots of sensors are there, starting from accelerometer, pressure, temperature, humidity, barometer, fingerprint, gyroscope, magnetometer, pedometer, everything is there. I will go through few slides what we have developed, and everything can be connected. All those things can be connected for with IoT, depending on the applications or depending on the need. And in our case, particularly, main emphasis that all of you have gone through that India Semiconductor Mission. So in 2020, they have started, and they are initiating some India semiconductor manufacturing within the country. So that is very much required. But again, the industry cooperation and industry involvement is also very much there. So our, as a national laboratory, our responsibility is also there, how to contribute to that India Semiconductor Mission in various ways. And for that, some of the device, we have the device fabrication facility to some extent, but you see that for that micro device fabrication, the facility we need, the clean room facility. The where we are fabricating the devices, that should be very much clean, because there is, you know, all of you are knowing that when we are making a circuit, there is a connection. And when it is very compact devices, in micro size devices, the connectivity will also be in micro level. And where we are fabricating those devices, if there are very few dust particles are also in the micro size. So during the fabrication process, when you are fabricating or patterning the devices, if some dust particles come on top of that circuits, so there will be disconnectivity, or there will be the connectivity between the two lines. So device will be damaged. So very much clean room facility should be there. And our clean room was the first clean room in India for semiconductor device fabrication. But the point is that after that, we need to augment with our facilities with various sophisticated facilities, because nowadays all the devices or sensors are much more compact. It will be, sometimes it is sub-micron level or nano level. But if we put those very much sophisticated facility within this clean room, because this is the old clean room and after that it is not being renovated. So those equipment will also damage, and we cannot get the environment to fabricate the devices. So first, our emphasis is to go for the new clean room, and then augmentation of all new facilities there to create the that nano level or sub-micron level device fabrication. So that's why whatever devices we are fabricating, what are the possibilities, based on that we are fabricating the device here, and which nano level, sub-micron level fabrication is not possible, we are designing here and we are fabricating somewhere else with some foundries. So that is fabless. So our approach is fabrication as well as fabless approach. So we are designing here. So there is no restriction for designing the devices here. But if there is a limitation for the fabrication of those devices in sub-micro level, we can get it fabricated somewhere else where it is being fabricated. And after that, we can package there itself. We can package here also because we have our fabrication packaging facilities here. So few examples on that. What I mentioned, I will go very briefly, quickly, because this is the very inner side of the devices. What I mentioned that LED devices based on gallium nitride materials. And as the material is very much promising, because so many devices and so many promising devices we can fabricate using those material. So we have our MOCVD reactor by which we can grow the material. So we can design the devices, we can grow the material devices, we can fabricate the devices, and we can, after that, we can test and characterize the devices to some extent. Because testing and characterization of the devices is depending on the what type of devices we are fabricating. So we need to augment time and again the devices for the equipment for the testing of those devices. So this is on one example that this is the structure of the LED devices, that is called multi-quantum well structure. I will not go in detail because this is not in your domain particularly. If anybody is interested, you may ask afterwards. We grow the material on sapphire substrate and various structure with different composition of gallium nitride materials. We grow the material, and those are the wafers. We can grow the material, and after growth of that material, we can go for patterning of this type of structure for maximize the light output through light extraction efficiency, optimal. So those are a few results that when we are driving, what we are getting the light output, and comparison with different LED when we grow the material in different wafers. Similarly, UV LEDs as well. It is for that UV LED also gallium nitride is the base material, and with aluminum composition we can go for that emission towards UV light. So for blue and white, I just forgot to mention, for blue and white, whatever the white LEDs we are seeing everywhere, indoor and outdoor application, blue-white is its basis. So for that we have to fabricate first the blue LED in the range of 450-460 nanometers emission wavelength, and after that we need to go for that yellow phosphor combination. So all of you know that the light blue and yellow gives a combination of white. So we first fabricate the blue LED, and then yellow phosphor we mix up with some elastic material, that is polymer, with uniform composition, and we deposit on top of that. And what if the emission we are getting? White. So it is everywhere. So that is blue and white LED. And this UV LED is for aluminum composition. With different aluminum composition, we can go for the emission wavelength changing of that one. But the main thing is there is a restriction of aluminum composition. If we go more and more aluminum composition, we can go more and more in the UV side. That means UVC side. But the problem is if we go for more and more UV side, by aluminum composition, the efficiency goes down. So some technological restrictions are there. People are working all over the world. So those how to improve further efficiency in various ways people are working. So on that also we are working. So those are the devices we have already fabricated in our institute. Gallium nitride based blue LEDs, 455 nanometer, white on top of blue LED if we go for that yellow phosphor, and that gives the efficiency in the commercial level we are getting now, 70 to 98 lumen per watt. We can go for the green LEDs as well in the range of 525 nanometer. For various defense application, we can use that one in the same material, gallium nitride, and UV LEDs as well. So those are the figures, some of the pictures on what we have fabricated. Those are again few things that mainly these LEDs are current driven, and that is DC current. But we can make the circuit, or you can make the LEDs in micro level and getting interconnected in the chips itself, so that in a combination we can directly use it through AC. Only the thing is AC, for the positive half cycle the currents is there and negative half cycle is not there, so some flickering is there. So we need to refine that one. We need to check that one so that we can use that direct AC LED as well. So various micro LED components are being interconnected within the devices, within the chip itself. So those are the micro chips and getting interconnected kind of thing. The other thing is, go for next, phosphor-free white LED. So that is also another very important thing, because that blue LED, that is solid state material, all semiconducting material. The deterioration with time is not that much there. But when we go for that yellow phosphor coating, yellow phosphor we are mixing some with polymer. But polymer degrades with time. But for getting the white LED, we need to go for that yellow phosphor coating on top of blue. So obviously with time, some deterioration of efficiency of white LED will be there because of the deterioration of the quality of polymer, that polymer material. But we can avoid that one also. So without using that polymer or yellow phosphor, we can go for that white LED. So we are working on that also. But again, it is on the research sheet, but here the efficiency is less. So worldwide work is going on. So whatever the yellow component we are getting by using phosphor, we need to replace with the semiconductor fabrication itself. So we have done that. So few other sensors that we have fabricated and that can be connected with these IoT applications as well. One of those is the gallium nitride, again gallium nitride based HEMT device, that is high electron mobility transistor, that we are not going into the structure, that is the structure of that devices. But the application, these devices can be used for biosensing applications. So they have used for breast cancer detection technique, and these devices can also be with slightly different structure. It can be used for power application as well. So nowadays for gallium nitride based power amplifier are very much used. So for e-vehicle, all those things, so these type of devices are very much important. For 5G communication also they are being used. So that is depending on the material gallium nitride as it is having high breakdown voltage. For switching application, for other isolating application, we can use that one. Earlier we have fabricated those lasers. Again, the emission of the laser, you all know that emission of the laser, that depends on the material where the quantum oil is there. Based on that material, the emission band gap of that material, the emission is there. So this is L gas, in gas That means gallium arsenide is the main component and indium is the composition. We are using that one. And the 980 nanometer laser diode we have developed. So that 980 nanometer laser is very important, particularly for amplification of erbium doped fiber amplifier. So if you heard about that EDFA, erbium doped fiber amplifier, that is optical fiber based system, and it is having the in an optical fiber, if we dope the erbium rare earth, so it is having the spontaneous emission in the range of 1530 to 1565 nanometer, which is the optical communication range. And to amplify that one, we need to pump the erbium doped fiber using that 980 nanometer laser. So that is the use and that is the purpose of creating that 980 nanometer laser. So for optical communication, and you just have seen various cable TV or wherever the fiber to the home networking is there. So they use ADFA amplifier, and if they use the ADFA amplifier, they need to pump with the 980 nanometer laser. We have developed this indium phosphide based detector as well. So this is again in-gas indium phosphide. Indium phosphide is the material again that can be used for detector and in the optical window. So it is in 1310 and 1550 nanometer range. So that has also been developed. Okay, so go to the previous one. So there are other sensors and transmitters we have developed. So all those sensors can be used in IoTs as well. And what I mentioned that not only the sensors, but along with that the transmitter. So the output in the form of current or voltage. Now you can use that current and voltage in so many configurations in your circuit. Depending on the requirement, you can use the sensor. Here, just for example, RTD based temperature sensor we have developed up to measurement of 120 degrees centigrade, and with transmitter with various resolution is there, and all those what we have developed, those depending on the demand from industry, from some defense organization kind of thing. Just like here, we have developed this for Indian Navy and we have supplied to them. So once technology is there, is developed, and that can be customized for various applications, for various specifications. Similarly, for pressure sensor, again we developed in different ranges of pressure sensor. There is again huge demand from various industries for various pressure sensors. So we can go ahead with their spec as well. Only the thing is technology we need to customize according to that one. So here just now we have developed 0 to 10 bar and 0 to 1 bar specification. So according to the dynamic range, the resolution will be different. Again, this is for Indian Navy. We have fabricated and we have supplied to them. At the same time, we have supplied to ISRO as well and another CSR laboratory in Bangalore, NAL. FET-based pH meter, field effect transistor based pH meter. What we generally do for pH measurement, we use litmus paper in general. That is the very much cost effective. But if we need to connect with some circuitry based on which we need to control something, so that possibility will not be there. So in that case, we need to have some devices which is having the output in terms of current or voltage. So this may be the devices for pH testing and pH monitoring, and based on that we can go for interconnectivity with some controlling action or switching action. And these devices are very much may be required for different agro-based applications or food processing application or water quality monitoring, those things. Acoustic sensor, that is also MEMS based, micro electromechanical system, very miniaturized. This is the structure, and this is fabricated on top of a Pyrex glass. And particularly these type of devices we have fabricated, and that has been supplied to ISRO, and that is being used in 12 successive PSLV launch, polar satellite vehicle launch vehicle. They have used those type of devices. Similarly, MEMS-based other sensors, magnetic field sensors. Again, it is the devices. You can see that this is the 2-inch wafer, and number of devices we can fabricate within these devices: 1, 2, 3, 4, 5, 25. So 25 number of devices being fabricated in 2-inch wafer, and all those devices are cantilever based. Each individual device you can see here, and this is the specification. Based on the requirement, the material and structure will be there, and that can be used for navigation purpose or biomedical application as well. This is another one, that capacitive micro-machined ultrasonic transducer, and it is also this is the structure on the wafer, and based on that sensing, we can check what is the resonance wavelength on different analytes, and we can take action according to that. If it is for monitoring, we can take the decision. The quality of those, just like for this example, we can use that for milk quality measurement. So we can go for that quality of the milk, whether how good or bad is there, and according to that we can give our decision or take further action. Magnetometer, again, this is the structure, very critical structure and accurate structure. For navigation purpose we can use, and for other labs we have fabricated that one. Accelerometer, it is also MEMS based, and nowadays you can you know that accelerometer, gyroscope, all those devices are in every mobile phone. So these devices we have fabricated, although it is one axis, so various axes also we can fabricate, and that can be used for various applications. In navigation, automobile, defense, space, everywhere we can use that one. LTCC based, that low temperature co-fire ceramic based devices also, what I mentioned, that is this material basically for packaging devices, but not only packaging, each individual devices, just like micro heater. Here it is one type of micro heater. So IR emitter, as IR emitter also we can use that material as well. Few applications. So what the devices we have fabricated and what are available in the market, we combine those things for a few IoT applications. Just 2-3 examples I will give. This one example is a human drowsiness detection system for drivers and industrial workers. That means when anybody drives, he may be the driver may be fatigued for long driving, or the worker may be fatigued during their industrial work. So based on few parameters, so here the objective was the issues related to monitoring and detecting the drowsiness behavior through hybrid approach and behavior and physiological features. So what they have gone for, that monitor of driver's facial parameter, and those facial parameters gives you the drowsiness symptom like yawning, eye blinking, rate of eye blinks, that is per close. That means how much percentage of your eyelid is closed, and head movement. So all those things are the parameter they have considered for drowsiness. So all of you can understand that when anybody is feeling drowsiness, so those may be the symptom. And also they have taken another physiological parameter, that is ECG, electrocardiograph. So these combining these two results they have taken, and according to that they give some alarm system, or if it is IoT based, so in industry, so they can go for some send the signal to supervisor as well, kind of thing. So this is very much important. When you visit Siri, you can check this system as well. So this type of work here, Dr. Sanjay Singh, and in Chennai Center, Satish Bindal and his team, they are working. This is another thing Dr. Sattam Srivastav here, he has developed, that remote vital information and surveillance system for elderly and disabled person. So it is similar to this smartwatch kind of thing. You can wear that one, that is wearable devices, and those monitors that can be connected with that one. So it can use that blood sugar. You can give the information of blood sugar. It can give the heart rate, oxygen, temperature, and the blood pressure as well. So some resolution is there, and according to that, that can be connected to his personal doctors as well. So it is for individual health monitoring, as well as if there is any alarm, the data is being stored in cloud, and from that it can be sent to his personal doctor as well. The other is IoT-enabled colposcope. Again, Dr. Sattam Srivastav, he has developed. And both this and the previous thing, those have been transferred to some companies, startups. They have taken these technologies, and they are going for the production, and after calibration, they are selling those devices also. So this is also colposcope. So this is the device, and after monitoring that one, any actually cervical cancer, they can detect, and after that, and this is the image-based one. So you can go for that imaging of those portion, and after that, that can be sent to his doctor, and he can take the decision according to that. If we check the future of the IoT, it is huge. What I mentioned earlier, and if we check the statistics, that in 2003, if we see the data, world population was 6.3 billion, and the number of device connected around 500 million. So if we take the percentage of devices connected devices per person, it is 0.08%. And if we check in 2010, see, by this time itself, the number of devices crossed the number of population. So here, number of population 6.8, number of device connected is crossed that one. So 12.5 billion. So it is already 1.84. And after 5 years, you check this one, that 7.2 billion, and here it is 25. So it is going almost exponentially increasing. So by 2020, you see that 50 billion devices, various devices are being connected. So per person, if we check that per person 6.58, now around 7 devices per person worldwide being connected through IoT. So in that speed, the IoT connectivity is going on. So check the market of IoT in this case. And so ultimately, this is the future I have taken again from some website, Libelium Smart World. So where everything is smart, everything is being interconnected with IoT to go for that improved quality of life with better efficiency, minimize or using optimal energy. So everything should be there. And obviously, if we use that one, if we use each and everything in optimally, so the energy we can store for the next generation as well. So here, for example, checking that air pollution, forest fire detection, wine quality enhancement, off-screen care, sportsman care, structural health, smartphone detection, everything will be there in our daily life so that each can be used optimally. Our life will be improved in quality, energy will be optimally used. So, from my point or from our group's point, we are working on those devices itself, not for IoT particularly from my group's aspect, but the devices which may be connected through IoT for different uses based on the requirement. So compound semiconductor based devices, and those may be gallium nitride, gallium arsenide, silicon carbide or diamond based, in different LEDs or diodes, transistors and power devices for power amplification application or various sensing applications. Silicon photonics is another area for communication. Nanostructured devices for sensor platform, and those platforms can be customized for various applications as well. Obviously, adopting fab and fabless, whatever is possible, we can fabricate here. Whichever it is not possible, we can design here, we can fabricate somewhere else. And skill development is very much part of our emphasis. And I can show you another slide and how to contribute towards a national semiconductor mission. That is one thing. So this is in conclusion that I have given the overview of what are the semiconductor devices, few insights, few details that can be connected to IoT, and what are the activities on those devices are going on in CD. And this program, in fact, those who are interested for device fabrication and semiconductor devices, it is very much useful for them as well. You can pass on to your colleagues as well. You may be interested, you may not be interested because you are very much interested in IoT, but those who are interested in semiconductor devices fabrication particularly, because what we have seen in various interactions, various interviews, that everybody, they know about semiconductor device theoretically, but they don't have any experience or exposure for device fabrication. They don't know how the semiconductor wafer looks like, what are the photolithographic process. So here in this program, this is 2 weeks program, and on nominal payment basis, but at least they can have an exposure that how the device is designed that they can do. But here, starting from design of that devices, fabrication of those devices, and testing of those devices. So various unit process fabrication process will be there, starting from wafer cleaning, lithography, patterning, metallization, testing, everything out there, so that at least they have some overview how device can be fabricated. Okay, so now we can interact. Again, I am not saying that I am not the expert on IoT, but when you visit our lab, you can check with our colleagues that they have fabricated, they have developed IoT-based devices as well. And now my emphasis was that, because when the director requested me, I thought, okay, so it is a bit different in that perspective, that it is not directly related to your IT, but it is indirectly related to your IT. In that sense, what are the devices can be connected through your IT?
First question is from my side. So it is in a structure of LED structure is there. So in a LED structure, there is a contact is fabricated from the some indium material.
Contact, in fact, contact of indium, that can be indium, using indium, that may be Jugaad basis. That is not the real case. In fact, that is
because better materials are available.
Yeah.
Because for the structure side. So if we go for the like other material which is better than indium.
Yes, yes. That is also another part of research. And you see, there is a P contact as well as there is N contact. And for P contact, we need to use one material, and not only one material, that is a combination of material. And for N contact, there is another combination of material. Just like LEDs, for P contact, we are using nickel gold. Very thin layer of nickel on top of that, we go for gold.
Yes, sir.
So
sometimes it is a tri-layer also. Aluminium, nickel,
for N-type contact, we are going for four level contact. That is titanium, aluminum, nickel, gold. So that kind of, so that depends on what material is there, what is the work function difference between semiconductor metal, because semiconductor metal junction is not ohmic. We have to go for ohmic contact.
Yes.
Initially, when we form, that will be Schottky contact. Then we need to go for annealing of that one. So we need to go for choice of that material or combination of material, and then some process to optimize that.
Thank you, sir.
Sir, my name is Surya. I'm from Andhra Pradesh, sir. Sir, actually, my college has got autonomous status. So what I want to know is that how can we implement, because semiconductor, doping of N-type and P-type are there in the books for a long time. Now we are forming a B-voice. How can we, because now it is the area where everywhere in the world is now trying to implement GAN. How can we include that into our curriculum?
See, for semiconductor area is working in that area is very cost consuming. You can consider that, because the establishment of one semiconductor facility maybe depending on what devices you want to fabricate. Please sit down. So based on that, if we want to establish any semiconductor device fabrication facility, that may be more than 200 crores kind of thing.
What I want to know is that including the know-how of curriculum in the curriculum, is it possible to go? Because
the thing is, what you mentioned, that to establish that everywhere it is not possible. But that's why we have incorporated this type of program. So, but it is not again every time it is running. So you need to contact. We are going for batches of 15 to 20, and there are some slots. We are giving the training without disturbing what are the ongoing projects are going on. But definitely per year, 4 or 5 batches we run. So So you can give me the contact, or you can directly, go through CDO website, you can directly contact them also. When you visit there, if I met, I can introduce with the concerned person, Dr. Manish Methu, and Skill Development, Dr. Ashok Chauhan. So that is, so it is our social responsibility as well, because they know the theoretically, but they don't know how practically happens. At least they have some exposure. Wafer looks like that, photolithography process is that, metallization is doing in that way, doping can be done in various ways. So what are the processes?
Yes, sir. Sir, actually, as you said, everybody will know at third year level. Students have.
The thing is, they have to have the exposure, theoretical exposure.
Yes, yes, sir. Sir, but many of the students, because GN don't have, even I too don't know what are the compositions, like you said, for the N-type doping and P-type doping. For silicon-based wafers, everybody knows, because it is in the textbooks for a long time. But how can we at least give the theoretical exposure for the students for the GN?
GN.
Yes, sir.
There are few textbooks and journals. Mainly, whatever the updated area, we need to go through journals. And if you go through review journals, review papers of any journal, very recent, they can cover almost the main thing. So that is the thing. And along with that, if they have at least some exposure, hands-on exposure, it will be much better to grasp all those things after that's hands-on.
Thank you.
One more question, sir. I have.
Yeah.
Because you have just discussed about the national semiconductor policy. So, we also have a national education policy. So my question is regarding semiconductor policy. So because we don't know about the semiconductor policy, what is how to use for the students and for the faculty members. So can you give us some?
In fact, semiconductor policy, according to government's policy, even now, in my opinion or in my perspective, government is also not that much clear how to proceed. They have understanding that they need to work on that. We need to go for that semiconductor manufacturing within country, and not with government stake, with industry stake as well, so that they should have some responsibility as well. But so far it is working. 3 years is going on. 3 years time has passed. But some industries come, they again going back. They are giving certain requirement, the condition, they are not satisfied kind of thing, they are working. But this program, even before COVID, we thought of and we introduced. But after that, COVID started, so we could not implement that one. And when India Semiconductor Mission in 2020 came, we thought that it may be our biggest contribution towards the semiconductor mission. Because whatever the manufacturing industry comes to India, or they establish any company or any organization, they need manpower. But India don't have trained manpower at all. They can invest money, they can take the equipment from outside, but manpower they cannot come. Manpower they should generate here itself. So that may be a good contribution from our side.
India Semiconductor Mission, basically what the Prime Minister wants, he wants to fabrication is from inside India. But because problem is that
Investment was one thing, that's why industry comes and they are going back again.
Yes,
that is one thing. The second thing is manpower, that we can In one day, that is not possible. So, so this is one point that the students may have certain overview about the processes, how semiconductor devices are being fabricated and various processes. But industry, what industry needs, they may need certain expertise in certain areas or unit process. Suppose they need to recruit some person, few persons on lithography itself. So the person should be expert in lithography itself. He may not be efficient in other process optimization or process operation, but maybe with that one also. So that can also be customized. That program can also be customized. So based on the requirement, but this is according to the government's policy. But from educational institute, obviously they don't need the expertise on lithography only, expertise on metallurgy only. They need the exposure for the students or faculty also about the overall process of fabrication.
Still, I will ask one question.
Please.
Sir, like for EV chargers, I have seen in one slide you have mentioned about GaN in EV charging. So we are aware of silicon carbide that is being used in EV chargers. So is it we are moving like for fast chargers and super fast chargers? That's why we are including GaN in this for increasing the power efficiency, or any another benefits are also there?
See, silicon carbide is one area, and power charger as well as gallium nitride can also be done. But we have to, as industry, they can see, or they have to see for what power level and for what efficiency level, which is better. In both the cases, for high power, silicon carbide as well as gallium nitride, both are good. But gallium nitride may be effective up to certain level, 1 kilo electron volt, 1.2 kilo electron volt kind of thing. Above that, silicon carbide may be good. So below that power, silicon carbide may not be that much affordable, because the silicon carbide is costly material. Although gallium nitride is also costly material, but gallium nitride can be grown on top of sapphire substrate. Sapphire substrate is very low cost now. So that is the thing. So, but both are useful for high power in EV.
Thank you, sir.
Good morning, sir. I am Suchandan. I'm very curious to know about the for master program and the PhD program in semiconductor field in the CSI city.
Yeah, that good. It is good that from my lecture you got interested in semiconductor area, but this is not my intention that from IOT field I extract you towards the semiconductor. But for doing PhD, ACSI, you have heard of ACSI now? Academy of Council and Innovative Research. So ACSI is a virtual institute, and in various CSIR laboratories, including CIRI, they are hosting those. So around 16, 17 CSIR institute they are hosting. But definitely if you want to go for masters or not masters, nowadays masters cannot be done individually. It is integrated dual degree PhD and PhD. So for MS, although now this science program is also there. So that means whoever has done his MSc and BTech, they can join their IDDP program, integrated dual degree PhD. That will give you the MTech degree as well as after that PhD degree. But the condition is that the MTech degree will be valid only his completion of PhD degree. And the person who has done already MTech, after MTech, he can directly join to PhD degree. But there are 2 sessions, in August session and in January session. Admissions are open. Advertisements come from ACSR in newspaper as well as in website. So for August, I think during April itself, they give the website. For January, they give, I think, September, October. For January session, we have just completed the interview. All this screening interview is over. Selection has been done. So yearly 2, in August session, both integrated dual degree PhD and PhD candidates can apply. That you have to apply through online. Advertisement comes, you have to register yourself and you have to apply accordingly. And after that, shortlisting and interview is there, and after that you can join. For August session, both integrated dual degree PhD and PhD program. For January session, only PhD.
Thank you, sir.
No more question? Huh? Sorry?
Uttam radar, ASA radar. Now India is being developed. India is developing.
Which radar?
Uttam, sir. Uttam radar.
Uttam radar.
Yeah, sir. Sir, our contribution is there in the Uttam radar.
Okay, okay. So that radar, for what purpose they are doing?
They are doing for identification of targets from the aircraft.
Okay.
They are now trying. Actually, they have implemented for gallium arsenide. Now they are trying for gallium nitride thing, as the efficiency of the radar is more.
Yeah. Gallium nitride, in that sense, efficiency and radiation resistant, more radiation resistant material. So target material, as target material will be benefit you can get.
Thank you, sir.
Thank you, sir, for your enlightening words. Now I request our FDP coordinator to present a memento as a token of gratitude to our esteemed guest. Thank you, sir. Now I invite all the participants for the article discussion.